In this question, a ring of radius A contains a charge small q distributed uniformly over its length. Find the electric field at a point on the axis of the ring at the distance x from the center. Let's understand this question with a figure. Here in this figure, we have a ring, and this ring has a charge distribution of plus q. And there is a point P. The distance of this point from the center is x distance. We have to find what is the electric field acting at point P. So to solve this question, let's take this a small portion of a ring. If we consider this is our small portion, this we can write it as dq. That's the small region of the charge. In this region, how much charge is acting, that's dq. So because of this dq, this point P will get some amount of electric field. So this is our electric field and this is our dE. Now the distance between, let's make this point as A and this is B. So the distance between AP is equal to root of AS square plus x square. So how we got this value? We already know that OP is equal to x and OA is equal to A. So if you use the Pythagoras theorem, we can find the value of AP. It can represent it as R. Now this is our theta. So what is the value of cos theta? Cos theta is equal to x by root of a square plus x square. Now we have to find what is the value of electric field. This is a small component of it. So if we make the component of this dE, so we can stretch it here. This is our theta. So we can write it dE cos theta, and down it is dE sin theta. Now suppose we took one of the point here. If we have many points, let's take if I make one point at this point here down. So based on that, we might get another electric field in this direction. This is also dE. If we make the component, this is our dE cos theta, and here it is dE sin theta. So what you will notice that x-axis components are getting added. Means previously it was dE cos theta, now one more dE cos theta. So it's getting added when we are taking more of the components. But you see that y-axis directions are different. This is upward direction and here it is downward direction. So net electric field along the y-axis will always be 0. So we can say that total electric field is nothing but the integration of dE cos theta. So electric field of a point charge is equal to 1 by 4 pi epsilon naught dq by r square. So r value we know that is root of a square plus x square. So dE can also be written as 1 by 4 pi epsilon naught dq a square plus x square. So we got the value of dE, and if we have to find the net electric field, it is equal to dE cos theta. So we need to substitute the values here. So dE we already got it, it's 1 by 4 pi epsilon naught dq a square plus x square, and the cos theta is equal to x by root of a square plus x square into x by root of a square plus x square. So for the solving, this is our integration here. So we can say that 1 by 4 pi epsilon naught into x upon a square plus x square 3 by 2 into dq. So everywhere charge is equally distributed, so integration of dq will be the total charge. So if you substitute this here, total electric field is equal to q into x upon 4 pi epsilon naught a square plus x square 3 by 2. So this is the answer of this question.